Okay, do you see my first opening slide? And I'm just going to advance one and see if you follow me.
Looks good.
Okay, awesome, great. Well, thanks so much for inviting me to talk with you all today. I'm sorry that I can't be there in person. I do see some familiar names there, at least in terms of folks that have joined the meeting remotely. So some of you may be aware of this work already, but this is going to be an overview presentation of some work that has been underway for at least some time now through the Bureau of Reclamation. I myself am a hydrologist and civil engineer with the Bureau of Reclamation in our Technical Service Center in Denver. So I'm going to be talking about the revised natural flow study that, as I said, is already underway. And this is, like I said, largely going to be an overview presentation with some suggestions for preliminary results or results that will come soon that we hope to share, in the near term with this group and others throughout the basin. So I plan to give an overview of the study, share kind of what the overall extent is, what are the technical analyses that go into estimating natural flows, what are we doing now that is different from what has been done in the past, how are we handling sensitivity and uncertainty around all of the different analyses that are being conducted right now, what is our technical review process, and then where are we in the study and where are we heading, so what's the timeline. And as an overview, so with this study, we are estimating daily flows at chosen locations throughout the Klamath Basin, upstream of the Trinity River confluence. And with that, removing significant effects of human development. So we're calling this sort of pre-development flows. This is distinguished from the term undepleted flows that many of you may be aware of. And that was really the focus of the natural flow study that was done about 20 years ago in 2005 timeframe. That really focused on removing the effects of the Klamath project in agriculture on flows. And in this case, we're broadening that scope, really trying to understand the effects of various changes throughout the basin, including agricultural effects, but also land use, vegetation changes, and things like that. So the aim is to simulate flows, assuming pre-development conditions under relatively current climate. So we're still working with climate and weather information from water years 1981 through 2020. Really to answer the question is, what is the best estimate of what natural flows would have been in various places in the basin over this time period between 1980 and 2000 if development had not occurred. So also considering climate change has been occurring. So really trying to focus on current climate timeframe and what flows may have been without development. So those elements that we're considering or changing as part of this natural flow study. So we're considering large-scale landscape landscape scale vegetation, lake evaporation and how maybe surface areas of water bodies have changed over time, wetland areas that maybe, particularly in the upper basin, were there historically and are not now. How have those changed? Agricultural development, water management and flood control structures. So the infrastructure in place for water management, municipal development, major channel modifications where we have the information and can understand what a pre-development and current condition is, because that in itself is a challenge. Dams for hydropower generation, clearly, and then other kinds of infrastructure like levees, roads, railroads, and so forth. And really the hope is to develop the best estimates of natural flows that we can using current science, that we have available to us. So we have a number of study partners that we're working with to tackle some of these areas. So what's the motivation behind the revised natural flow study? One is that there were a number of science initiatives that came forward maybe 3 or so years ago, identified by the Bureau of Reclamation. And this is one of those efforts that was identified. So really identifying this need for foundational information to support other kinds of studies, like habitat studies, for example, drought planning, water supply and allocation planning, and so forth. Really, the natural flow estimates are seen as kind of a baseline, and the flows that were developed in the 2005 era are really still, 20 years later, probably the information that we have available, the best information we have available to us to work with. So this is an effort to really rebuild that scientific understanding. And with the 2005 study, I'm sure as many of you are aware, there were a number of deficiencies that were identified with that, or critiques for improvement. And so we are considering all of those as we move forward. So study assumptions. There are many. These are just a few of those. But one assumption is that pre-development landscape conditions are represented by the earliest available maps and documents that we can find. So these are generally going back to the mid to late 1800s. So there's no single date at which we're trying to represent a pre-development condition. It depends on the kind of information that we have available to us. So we may have a vegetation map from, 1880 something, and a topo map from early 1900s, and we're just trying to incorporate all of that information. Native inhabitants. So another assumption is that native inhabitants did not significantly alter the natural condition of the basin. So really, the intent is to kind of look at the development that's occurred over the last 100, 150 years or so. Quantifying changes between current and pre-development landscape conditions. So the assumption is that by doing this, it'll really allow us to calculate the best estimate of natural stream flows that we can. And I'll go through some of the elements that go into this, technically speaking, in a moment. And of course, there are a number of other assumptions that are associated with each piece of the analysis. We're, in terms of representing open water evaporation, there are a number of assumptions that go into the modeling of that. A number of assumptions that go into, say, open ET estimates of consumptive use and so forth. So we have a way to sort of incorporate various uncertainties throughout these analyses. The study extent. So we've generally organized the study in 3 phases, working sort of our way from upstream to downstream. The phase 1, generally speaking, is upstream of Link River Dam in the Upper Klamath Basin. Phase 2, generally speaking, upstream of Iron Gate. And then phase 3, upstream of the Trinity River confluence. This, in part, it was organized this way in part to because there was a need to focus on the upper basin first, with the idea that maybe that information could be used for water supply planning, and that was a priority. Also, another means for the organization or motivation for the organization is we're very much building on existing tools and information and models, and those models have various spatial extents of their own. So this structure kind of loosely coincides with the available models that we are using and further developing. So this is the list of study locations as we have them now. There are, I think, 12 or 13 locations throughout this region. So they're listed here for your reference later. But just to note that we do have locations on, say, the tributaries of the Scott and the Shasta as 2 examples. So getting into the analysis overview, again, this is very much a broad brush overview. happy to get into any details as folks might want, you know, as in terms of follow-on conversations after this meeting. But generally speaking, to estimate natural flows, we take the, you know, the observed flows that we have available to us. We essentially add back in current condition depletions or losses, add back in pre-development losses or depletions or consumptive uses, and then similarly, you know, add back in the water management effects to arrive at natural flow conditions. The idea is that we're building, we have various components that kind of go into this, and I'll describe those in a moment, but we generally speaking are building our models based on current conditions and then removing those development effects, so to speak, to then simulate natural conditions. So this is a high-level schematic of some of the components that go into this analysis, and those components that we're considering include consumptive use, precipitation runoff modeling, modeling of open water evaporation, municipal use, as I mentioned, groundwater and surface water interactions. So building the groundwater model with its current condition recharge and inputs and so forth, pumping losses and so forth, calibrating under that condition, removing those effects and simulating what groundwater conditions were, you know, without those effects. So the idea is to arrive at daily natural flow estimates for each of those locations that I listed there earlier, and then with the idea that there'll be kind of an uncertainty bound around each of those estimates to the best of our ability to do that. So this is getting into perhaps some more specifics on some of the features that are being considered or changed or are changing from current condition to pre-development condition. And those include things like, so under current conditions, so infrastructure I mentioned, agricultural development, including dams, reservoirs, all of those things, crop consumptive use, and trans-basin diversions. So for example, the Reclamation's Rogue River project interacts with the Klamath River Basin in the upper Klamath Basin there. So we are taking steps to remove the effects of those transboundary diversions. How lakes were modified, so potentially natural lakes where dams were constructed, which may be added to storage, so removing those effects. Reverse land subsidence, so we know in some places of the basin that agricultural development has led to land subsidence, so trying to reverse those effects, again, to the best that we can. Representing natural wetlands and how those wetland extents have changed. Vegetation and land cover changes, hydraulic controls. So for example, with Keno Dam, you know, that was built in place of or just downstream of a natural reef. So removing the effects of the dam and reestablishing the hydraulic control of the reef. That would be something that is part of this effort. So again, to the best of our ability, you know, we certainly acknowledge that there are lots of assumptions that we need to make in these different analyses, and so there are uncertainties associated with them. So we have a process to go through for each of the different kinds of analyses that we're doing, looking at sensitivities. So how are the models, for example, that we're using sensitive to certain choices, and accounting for those, and then having a process to sort of resample essentially those uncertainties to develop uncertainty bounds for each analysis that then will propagate into ultimately estimates of natural flow. Because you can imagine that uncertainties in a rainfall runoff model might impact groundwater modeling, and there are uncertainties also in that, and so they sort of cascade as you move forward kind of through the analysis. So how have we sort of brought the community in along with us as we've been doing this? Well, really, The information that we're relying on for the study really comes from those folks in the basin, and we are relying on all of you and certainly many others to identify historical information that we can base some of the pre-development assumptions on. For example, we've done a number of sort of virtual tours, if you can, so to speak, to go through and understand how different parts of the basin have changed. So the Sprague and Wood River basins, for example, we specifically looked at groundwater surface water interaction in those areas and talked through different pieces of information that we could draw from. Understanding wetlands changes, so we did a wetland extent tour. We've specifically done some conversations in one workshop centered around Jenny Creek, so the Rogue River transbasin diversion complexity. And we had a workshop last fall, which some of you I think attended. We'll do another, we'll keep doing those sort of periodic update workshops. We may do another one as early as this fall. In addition to that, we do periodic virtual engagement meetings. We have yet to do one this spring, so we'll do that sometime soon. And then at the end of the study, once all of the results are completed and reviewed, we'll do a full workshop to share final results. So as you can imagine, this is a very complex study, and the fact that we're embarking on daily natural flow estimates that involve all of these different complex analyses, that qualifies this work as being highly influential scientific assessment as classified by the Department of Interior. So there's a specific review process for that kind of study that we're following. We do have a peer review process and plan laid out and available publicly online. So there's some links here for that. And we have some external expert review for each element of the study. And yeah, I think that's what I wanted to mention there. So this is our timeline starting from essentially this month. So we've been underway with this study now for at least a year or two. And so many of these analyses are underway and starting to get reviewed. So I don't have, final results to share at this point, but we do have some analyses that are currently under review, which again leads us to potentially having a workshop as early as this fall to share some of those results. But we have hydraulics, ET modeling going on, groundwater modeling. So phase 1 and phase 2 essentially are, more or less we're doing those together, in part because of the individual model extents that go into it. And so we'll have natural flow estimates for the area upstream of Iron Gate, hopefully by the end of fiscal year 2024. We're in the process right now of scoping our phase 3 effort, which includes the Scott and Shasta basins and the sort of lower Klamath Basin. And we expect to come to the Shasta and Scott basins to do a tour this summer and collect additional information on changes in landscape there. So this group is certainly a wealth of information in that respect to us, and I may be reaching out to a number of you for additional information from the talks that you've given this morning. The idea is that the final study results for the full natural flow study will be done sometime in 2025. So we're still a little ways out from there. Here's a link to some additional information that I just want to share so that you all have this available. We do have a web page that has some resources that we're updating as we can and as we make things available, including fact sheets for some of the different technical analyses you may be interested in. And so myself, I'm Marketa McGuire. I'm the technical lead overall for the study. Bill Cronin is our Klamath Basin Area Office local project lead, and Caroline Ubing is our overall project manager who also works here in Denver. But any of us are happy to take questions later on. You can certainly reach out to us if you have any information that you think might be valuable for the study. And I believe that's all I have. Hopefully, I know I think I took 20 minutes, so I'm sorry I went a little long there.
No, that's just fine. Thank you, Marketa. Are there any questions from the room or from Zoom? Mike, I had a feeling.
So there's a lot of interlinked models there. I'm not sure the exact number, like 6 or 7. How do you keep the error from compounding possibly and the results spiraling kind of like out of control?
Yeah, no, Mike, that's a great question. And it kind of speaks to this like sensitivity and uncertainty analysis that I mentioned. And we know that that's a challenge. We know that there are uncertainties with each of these components, just like you pointed out. So what we can do is come up with our best estimate of what those flows would be based on calibrated models and so forth, and where those identify the error bounds for each of those different pieces and propagate those error bounds through any cascading analysis that comes after. So, we haven't completed it yet. So the hope is that the error bounds aren't, so large that it's not helpful. But that's the idea, is to just be as transparent as we can, identify where those uncertainties exist, and we have the modeling capability where we can actually incorporate those uncertainty bounds into subsequent analyses. So that's what we plan to do.
Great.
Does that answer the question?
Any other questions in the room? Dave?
I noticed that in your initial assumptions, there was a presumed that indigenous uses didn't affect vegetation, I think it was, or flow. And given the current emphasis on indigenous use of fire and vegetation management with that, is that really defensible in terms of mid-Klamath and lower Klamath?
Yeah, I mean, that's a great question. So I can only speak to the sort of the technical aspects and what that means for the technical analyses. And so what we can do reasonably is establish what we think as current conditions over that 1980 to 2020 timeframe in terms of what the vegetation or forest density, for example, was over that time, and then go to a pre-development condition and identify what we think the same forest density or landscape condition was in a pre-development time. Understanding that we don't have the capability to model how that changed, from year to year, for example. So that's the assumption that we need to make. We need to establish a pre-development condition that's constant or static and a current condition that's static. So what is that pre-development condition that we assume? Well, we have to use whatever information we have available to us to inform that. It might be maps, it might be, conversations with folks that know, what the landscape looked like, things of that nature. So I guess that's all I can say on a technical level to that question. And I think that's, the most defensible approach.
Great. Any other questions in the room? All right. Well, thanks everyone for listening in on a complex topic. So, and thank you, Marketa, for presenting.
Yeah.
Yeah.
Thank you.